let's review what we studied in last class. So in last class, we studied the waterfall model. So do you still remember the advantages of waterfall? What are the advantages?
Each step is fully defined before you move on.
Okay, so this is a simple step-by-step approach, right? Okay, very good. Then what else?
Well documented.
Well documented. Okay, yeah. So this is a very simple and disciplined approach. So it forces developers to think first and code second. And also, according to research, that requirements identified long before the programming is worthwhile in the effort, because research shows that half of the system failures are due to requirements issues. And also, time spent early is worthwhile because a bug found in early stages is cheaper to fix in terms of less money, time, and effort. And it also minimizes change to the requirements. So while looking for stable projects. Then what are the disadvantages? What are the disadvantages?
Takes a long time.
It may take a long time. Then what else?
Not easy to change.
Not easy to change. Okay. So it takes a static view. So basically, it is impossible to get one phase perfectly done before moving on to the next. So it leads to a lot of rework. And also, lengthy deliverables are poor communication mechanism, right? So people can overlook some of the important requirements by looking through a lengthy document. And also, business environment is changing. So waterfall takes a static view of the requirements. So these are the disadvantages. So we also studied two waterfall variants. They are, what are the two waterfall variants? They are by nature waterfalls, but parallel
Parallel and V.
system and V, right? Okay. So parallel development. The idea is a general design for the whole system is performed, and the project is divided into a series of sub-projects, then which can be designed and implemented in parallel. Then final integration of the system of the pieces will be performed, so the system is delivered. Then, what are the advantages for parallel development?
Time is saved.
Okay, more efficient, right? Okay. Then, what are the disadvantages?
Merging is complicated.
Merging can be difficult. So advantage is that it reduces the time to deliver the system, because changes in the business environment are less likely to produce need for rework. We know that changes will happen eventually. So if you can deliver the system sooner, then the chances to have changing requirements are smaller, right? So the idea is you should deliver your system as soon as possible. Then disadvantage is still the voluminous deliverables. So lengthy deliverables are problematic. Also, integration can be difficult because if some projects are not completely independent, then the decisions may affect each other. So V model. So what are the characteristics for V model? What makes V model special?
In every phase we test.
Okay, it pays explicit attention to testing. Okay, very good. So, as requirements are specified and components designed, testing for those elements is also defined. So each level of testing is clearly linked to a part of the analysis or design phase. Then advantage is that it improves the overall quality. But disadvantage is that it suffers the same problems as waterfall. Then, in order to overcome waterfall, the issues of waterfall, then since 1990, another methodology started to emerge. So the name is Rapid Application Development. Okay. So prototyping is representative for rapid application development. So prototyping can be classified into two categories. So do you which two categories?
Evolutionary.
Evolutionary and
So
Throwaway.
throwaway. Okay. So prototyping can be classified as throwaway or evolutional prototyping. So for throwaway prototyping, the focus is on well understood requirements or poorly understood requirements. Poorly. So throwaway prototyping, the prototype will be built as quickly as possible. So it's also called quick and dirty prototypes. Then only implement poorly understood requirements. Then the prototypes are used experimentally, which will be discarded eventually after the desired information is learned. The system, the advantage is that using prototypes to refine the key issues before the system is built, and it can lead to a more stable and reliable system. And for throwaway, the disadvantage is it takes longer time to deliver the system. But for the evolutionary, the focus is on confirm well understood requirements, and we do not discard the prototype. The prototype will evolve over time until it grows into the full-fledged system. Then the advantage for system prototyping is useful when users have difficulty expressing the requirements. The disadvantage is that the quality may not be good because it's lack of the careful methodical analysis. But the reason is that it doesn't have the formal design and formal implementation phase. So for a throwaway prototype, once all the information is obtained, then we have a formal design and formal implementation. So the quality is ensured. So in general, prototyping is a much better communication mechanism than waterfall because people have something to play with from an early stage. And prototypes can help with decision making. And the disadvantage is that users may get confused after seeing the prototype. And designers and developers may use the quick and dirty code, which leads to unstable and unexpected results. Then for extreme programming, so the test-driven development is a key technique used in extreme programming. So what's the idea? So code and or test case, which one is written first?
Test case.
So test-driven development means that before we write any code, we write a test. Then we check whether this test fails. Definitely the test will fail because you haven't written any code. Then you write the production code, then run all the tests. If some tests fail, then you fix the code. Then once all the tests succeed, you do the refactoring to clean up the code. So this is the idea of test-driven development. Do you still remember the 4 core values on which the extreme programming is built, is founded? The 4 core values. Courage, very good. Communication. What are the other 2? Simplicity, then feedback. So basically, extreme programming is built upon 4 core values, namely communication, simplicity, feedback, and courage. So keep in mind about these 4 core values. Then extreme programming, in extreme programming, testing and efficient coding are core. And extreme programming is good for small projects, which need stable and experienced team and small group of developers. Otherwise, the success is doubtful. It also requires a great deal of discipline. So not everybody is qualified to use extreme programming. So you should be experienced and also self-disciplined. The only code documentation is available, so maintenance is hard, and it requires on-site user input. So in the last class, I also mentioned code refactoring. So do you still remember what is code refactoring? During the coding, extreme programming favors peer programming. So it means that two people work on the same workstation. And also, people perform code refactoring from time to time. So what is code refactoring?
Changing the actual how the code is structured, but maintaining the actual like process of it, the output basically.
Yeah. So the interface normally remains the same. So the way of using your code remains the same, but the structure behind the scene may be changed. Okay. So next, I'd like to give you an example. So the first calculator in this world was built by HP. So the idea they used was the reverse polish notation. So do you know the reverse polish notation? For example, if we have 7 plus 8, actually we write it in a way that is 7, 8 plus, right? Okay, then which data structure is best to represent the reverse RPN, reverse polish notation? X, right? So for example, if we have 7 plus 8 times 2, then we can write it in a way that 7 plus 7, 8 plus then 2 multiply, right? Okay, so suppose this is the control. Now it is pointing to 7. What should you do? Suppose we use stack. When when it points to 7, what should you do? So suppose we scan the sequence from left to right. We push it to a stack. Then now it is pointing to 8. Then what should you do? Push. Then now it's pointing to plus. Pop. So you should pop 7 and 8, then plus them together. Then what? Then push the result back to the stack. Then now it's pointing to 2. So what should you do? Push. Then now it's pointing to multiplication. So you should pop both and multiply the values and push the result back. Okay. Okay. So now you see, I don't have code, so I only have an empty header file. So suppose we do everything in terms of Java. No, C++. Then we should follow the idea of test-driven, right? So before we write any code, then we should write
Test case.
We should write test case. So this is the CPP test, CPP unit test. Test group means that this test group includes many test cases. So test setup is the place where you set up all the necessary resources, allocated resources here. And test tear down is the place where you release all the resources. So now let me create a pointer. So here, this is the place where we allocate resources, right? So I create an object of pointer. So here, this is where we release the resources. So this is fine. Then we can start to design the test cases. So first, to write a test, we just put the test like this. Then we'll test the group name. And also, so suppose I test the initial value. Before I do anything, the calculator should return 0 to me. So longs equal means this is expected value, and also this is the RPN get current value. Okay, so before I set any value to the RPN calculator, it should show 0, right? Then let me, since we follow the piece rule, right? Keep it simple and stupid. So let's just use the simplest way to implement it. So next I test getter setter. So for RPN, I set a value. For example, I set 10. Then I should get the same values back, right? So this is the simplest. This is the simplest requirement. Okay. Now, if I try to compile my program, do you think that the program can be compiled?
No.
No, why?
I haven't written any of the code.
Yeah, because we haven't written any code yet. So now let me try to compile and see what would happen. So we'll see. It complains that RPN calculator doesn't have get current value or set current value and so forth. So remember that for extreme programming, we follow the KISS rule, right? So we choose the simplest way to implement the current system. So now let's just try to implement the two functions. So if we set a value to the calculator, then I should get same value back. Then still, we follow the KISS rule. Then in order to implement the idea, I can, for example, define an integer to retrieve the value. Then let me define the two operations. For example, void set current value. Then in get current value. Okay, so this is the header file. Then let me start to implement it in the RPN calculator. So first, void set current value. Value is equal to it's easy, right? And okay, get current value return. Okay, return value. So you see, if we follow the KISS rule, then instead of defining a stack, I define an integer value, right, to keep the current value, and I quickly implemented the RPN calculator, which satisfies the current set current value and get current value. Then, if now I compile the program, do you think that it can be compiled? So now let's try review the solution. So you see, the program is successfully compiled. Then let's go back to see the test cases. So you see, we in the first test case, we test before we do anything. The calculator should return 0, right? And the second test case is if we set a value, then we should get the same value back. So these are very fundamental requirements. So if I try to run it, do you think that the program can be run? Do you think that the program will be able to running? Okay, so now let's try. So it's called test driven. As you can see, yes. So you run it. Okay, so you see, I have 2 test cases. It says that one failure, then one success. And which one is failed? That is test in initial value. The expected value is 0, but the actual value is something like this. Now what happened?
Didn't initialize.
The reason is that I didn't initialize, right? So it means that we have identified a bug. So then I can initialize value in the constructor. So now let me review. Okay. Okay. Now, if I run the second time, it says that both test cases successfully passed. So this is a good thing, right? But in a real calculator, if we use a single value to hold the current value, so it is not enough, right? So for any meaningful calculator, we shouldn't just use a single integer variable to hold all the values. Instead, we should use. So which data structure we should use for the reverse Polish notation? Stack, right? Okay. Now this is the process of refactoring. So you see, we have the first version. Now we want to make change to the backend. So now let me change the integer to stack. So for example, I define a new type. Let me call it my stack. Let's go, call it value. Okay, so then go back to here. We should remove this part. Okay, so now value is stack. So for set current value, what should you do? We should put value dot push. So we push the value to the stack. Then for get current value, we should get value dot pop, right? Then return pop. Okay, so now let me try to compile the program. Okay, so I just made changes to the RPM calculator. I didn't change any test cases, right? But it can be compiled. Then if I try to run the test cases, do you think that the test case can be success? Can pass? Now let me try to run it. You see, the program crashed. Then can you figure out? So this brush very seriously. So can you figure out which part, it is not correct? For the current implementation. Which part is not right? So now, actually, we just have two operations: set current value. So, do you find any issues here? Huh?
No.
So this is fine, right? So we can push it. And do you see any issues here?
If we didn't set anything, then there's nothing in the stack.
Okay, so that's the issue. So if the current stack is empty, then you will get exception because basically it's non-pointer. So then in that case, we can set it to 0. Then we check if value dot size greater than 0, then top is equal to this one. Then we return the top. So let's try to compile the program. Okay, then in this process, I didn't make change to the test cases, right? Test cases remain the same. It means that the way of using my current code did not change, right? Okay, then let me try to run the test case. And you see, both test cases passed. So this is the idea of code refactoring. So is that clear? Code refactoring is that you keep the way of using your code the same, but you can revise the code behind the scenes. So for example, I changed the data structure from a single integer value to a stack, but I didn't change the test cases. So this is the idea of test-driven. Before we write code, we write a test case, and then we write code to pass the test cases. Then we revise, we perform code refactoring to make our code even better. But the way of using it remains the same. And throughout the process, the test cases remain the same. So is that clear for code refactoring? Okay, so do you have any questions? All right. So now you may have a question. When should we use a specific methodology? So this table lists the usefulness in developing systems. For example, if you have a system that doesn't have clear user requirements, then is waterfall a good choice? No. So how about parallel development? No. How about V model? No. Okay. Then how about system prototyping? No. Okay. So system prototyping is that we quickly deliver a prototype so that users may be inspired to think of the requirements. So system prototyping should be good, right? Mm-hmm. Okay. Then throw away prototyping. Yes. Okay, the same thing. Then extreme programming. No. So extreme programming is that we follow the KISS rule, right? So we start from a very simple solution, then we present the solution to the user. Then user will gradually add new requirements and so on and so forth. So then extreme programming can be good. Then if we are not familiar with the technology, then can waterfall do a good job? Yes. So if you are not familiar with the technology,
use the RAD prototype.
Yeah. So actually, if you are not familiar with technology, then waterfall is not a good choice because you spend all of the time on requirements, then step by step, eventually you find out that you don't know how to implement it. Right? And parallel development is also poor, right? The model by nature they are waterfalls. So this is a little tricky. So how about system prototyping?
That's good.
So system prototyping is that we do not discard the prototype, right? So we evolve the prototype over time. Then if you are not familiar with the technology, can you build a prototype with good quality? Then it can be difficult, right? So then how about throwaway prototyping? So the answer is yes. The reason is that we can use prototypes to get familiar with the technology. And once you have learned all the techniques, you throw away the prototypes and then you do a formal design, formal implementation. Then how about extreme programming? If you are unfamiliar with technology, then is extreme programming a good choice?
No.
No. The reason is that the team should be experienced, right? Should be experienced and well disciplined. So then this one is also tricky. So what if we want to build a complex system? So how about waterfall? So the answer is yes. So remember that in 1960s, people only had waterfall or even similar methodology, but the NASA still sent people to the moon. Okay, so the system was very complex, but waterfall can deal with complexity. So how about parallel development? So by nature, it is still waterfall, right? So it's good. Then V model is also good. And system prototyping, if it's very complex, it can be hard for system prototyping. And throwaway prototyping. Throwaway prototyping, even for complex systems, we will develop prototypes before we really start to build the real system, right? So it is still good. Then extreme programming.
No, it's with a small project.
Yeah, so it is also only suitable for small projects, right? Okay, then reliable. So we want to build something reliable. How about waterfall?
Good.
Yeah.
Yeah, waterfall is good. Then parallel development
Good.
is also good. So how about V model?
Definitely.
Yeah, so it should be excellent, right? Because it pays actual attention to testing. Then how about system prototyping? Actually, it may not be so good because it is lack of the methodical design and implementation. Then throwaway prototyping. Throwaway prototyping is also a good choice because anyway it has formal design, formal implementation. Then extreme programming is good. Then with short time schedule, so is waterfall a good choice?
No.
No. Then parallel development.
No.
Parallel development.
Good.
So it can be good because we divide the project into smaller pieces. Then how about V model? Poor. Then system prototyping. It is excellent because it evolves. Then how about throwaway prototyping?
No.
So it can
It's
be
not.
poorer than system prototyping, right?
Mhm.
Because it takes longer time to finish. Then extreme programming is also good. So then with schedule visibility, it means that we are sure whether we are ahead of the time or on schedule or behind the schedule. So is waterfall good? So waterfall for the schedule visibility, waterfall is not a good choice. Then how about parallel development? It is good, the visibility, due to the integration conflict, so it may not be as clear as other models. Then V model is also poor. So how about system prototyping? This one is good. Then throwaway prototyping. It is also good. Then extreme programming, good. Yeah, that's also good. So you see, in the future, if you want to guarantee the good quality, then which methodologies you should choose?
Feed model and throw away.
Throw away, right? So throw away prototyping, you see, besides good, just excellent. Excellent. So throw away prototyping is a very good choice. Then extreme programming, if you are sure that the system is not too complex and you have a very good team, then extreme programming is a good choice. Okay, so do you have any questions for what we discussed so far? Okay, so we only have a little time. Then for the midterm, still, let me say it about my time. So you are allowed to bring a cheat sheet, just the A4 paper size, and only one side can have content, and the other side should be blank. So that is the minimum requirement. And when you turn in your exam papers, please turn in the cheat sheet as well. So I want to make sure that you do not cheat on the cheat sheet. So I'm just kidding. So I believe you guys are honest, but you still need to bring the cheat sheet. Okay, the question is, this is just regular A4 paper. So let me show you, just of the regular size. So is that clear? Okay. Okay. So let's quickly review the dynamic model. So we have studied the dynamic model, but we will make in-depth study after this spring break. But now let's review what we studied on dynamic modeling. So from a use case, we can derive a dynamic model. So what is that? Which UML diagram we should draw based on the use case?
Activity
Sequence, right? That's a sequence diagram. So, and which part we should pay actual attention for the textual description in order to draw the sequence diagram? Flow events. So flow events is the most important part. So from flow events, we can translate a use case to a sequence diagram. So basically just something like this. And these messages represent operations defined on a participating object. Then who owns these messages? Or who owns these operations? So what is the rule?
Incoming should be the.
So the incoming or whoever receives, right? Whoever receives the messages own these operations. Then it means that the ticket machine should own select zone, insert coins, pick up change, pick up ticket. Then what is the visibility? So we studied the visibility, right? So what's the visibility of these operations? Public. So then you should have a class diagram like this. So is that clear? So in the future, if you read through a sequence diagram, you can identify objects and also identify operations defined for an object. You should also know the visibility of that of these operations. And later we found many additional objects such as zoom button, tariff, schedule, display. And what is this horizontal dashed arrow mean?
Data flow,
It means,
reverse bounce,
so the horizontal dashed arrow means
data flow.
data flow. So this, it means data flow. The idea is, the passenger select zone, then the zoom button look up price, then the price will be sent back to zoom button, then it displays the price on the display. Okay, so then what operations does tariff schedule have?
Look up price.
Look up price. Very good. So pay attention. The dash arrow data flow. So this one doesn't represent an operation. It only represents return value. So insert change. So we may iteratively insert many coins. Then how would you represent an iterative operation? So how would you represent iteration?
Star bond.
Star, right? So we put a star or asterisk in front of the operation. Then iteration is denoted by asterisk preceding the message name. Then sometimes, for example, we want to specify a condition. If the condition is satisfied, then we send a message. If the condition is not satisfied, the message won't be sent. Then how would you represent the condition?
The square bracket.
Square brackets, right? Okay. So for example, just like this. If own amount is less than 0 is true, then the message return change will be initiated. So the condition is denoted by the Boolean expression in brackets before the message name. Okay, then we in sequence diagram we can dynamically create objects, right? So create objects, then print and free. Then if I will, if I delete that object, or the lifetime of object ends by the end, then what is the symbol you represent the end of the lifeline? X. So if we put an X, it means that beyond that point, the object doesn't exist. Okay. So we also studied that why the ticket is a level lower than change processor. So you see, the ticket object is a level lower. So what's the reason?
Order of the activity. Sequence.
Sequence. Then can I move ticket back to here? No. Then why we put the object here?
The time elapses
Okay.
down.
So it means that at this point, this object doesn't exist yet, right? So the time elapsed from top to bottom. So this is how you rate the sequence diagram in terms of time. That's why we cannot swap free and print. You cannot call free before you call print. So keep in mind that this is intentional. So we put the ticket object a level lower because this is the point when this object is created. And if you put an X mark, it means that beyond that point, that object no longer exists. So if you read sequence diagram, you should read from top to bottom. Okay, so is that clear? Okay, then we have already known the relationship. So from use case diagram, we can derive a sequence diagram. So then the question is, do we have to draw a sequence diagram for every use case? So we know that for each use case, we can draw a sequence diagram, right? Then the question is, do we have to do it for every use case?
No.
So the answer is no. We only do the dynamic modeling for interesting use cases. So if use case are pretty complex, then we want to draw the sequence diagram to help us and understand the flow events, also help us identify some additional objects. But the idea is also we can draw a sequence diagram for every single use case, but we don't do it, right? Otherwise, we draw too many diagrams, and it reduces the readability of your design and analysis document. Okay, so that's all I have. Do you have any questions regarding homework, midterm, and so it's clear, right? Okay, then we will have the midterm on Wednesday. So yes.
What homework do you have?
The homework. So now all the homeworks have been due already, right? So, but I will release new homeworks after spring break, so you guys can enjoy spring break. Okay, thank you.